size of my samples, which is 7 samples from the left to the right. With the naked eyes, we can see that the samples show different color change with the different reaction of time. So from the yellowish to the brownish, it become more darker. So it approach the red end spectrum when the reaction time increase. That means it increase in particle size. Okay, this reaction mechanism I propose in my project to produce zinc cadmium selenide. Okay, the most attractive part is result and discussion. The first result from my research project is TEM analysis. So I put here in 3 different reaction time. From the first one at 0 minute, which is immediate reaction after I dope zinc, it show the smaller particles, and when the time increase for the reaction, the size become bigger and become agglomerate. So here we can clearly see that the particles are spherical and well dispersed quantum dots. The quantum dot size is increased with the increasing reaction time between 2 to 8 nanometer, and the tendency of agglomeration occur at longer reaction time. Okay, for the second result is ultraviolet visible spectra. So from the 7 sample, I can obtain the excitonic peak from 475 to 585 nanometer, which show that from the smaller size, the peak is shifted to the right, to the red end spectrum. So it shows that at longer reaction time, it becomes a red end spectrum. Okay, the Tox plot is obtained from the UV-based result when it desired from the equation below, the Tox equation. So the observed blue shade agrees with the optical band gap obtained through the Tox plot. So from the Tox plot, I obtained the band gap energy for zinc doped cadmium selenide. And I compare with the previous literature for the obtaining cadmium selenide band gap energy. So the band gap energy of quantum dots bothly decrease with the increasing of reaction time as the quantum dot size increase. So this phenomenon is called quantum confinement effect. Okay, the next one for FTIR spectra. Here for 0 minute, 90 minute for oleic acid and paraffin oil. The spectra exhibit well-defined main peaks, and this peak is 2852, 2921, and 2954 correspond to CH2 stretching. The band appears at 722 corresponding to CH2. The peak at 1377 shows the CH3 bending in paraffin oil. CH stretching behavior can be shown by a peak at 1461. And the presence of peak at 1707 indicates the signature of capping agent, which in this project is oleic acid bounded to zinc doped cadmium selenide quantum dots. And on the basis of FTIR data, the surface of zinc doped cadmium selenide quantum dot is mainly coated with oleic acid ligand. Okay, for the last result is for X-ray diffraction analysis. The XRD patterns of zinc dope are shown in several times in this analysis. Okay, the sample with shorter reaction time possess the broadest peak, and the full width half maximum can be obtained from the analysis, and it shows it's smaller with an increase in reaction time. And the broadening effect further examined by calculating the crystallite size from the Sterrer formula. So here given the formula with its constant, and from the formula I calculate the particle size, and by using the formula, the longer reaction time gave the bigger size of nanoparticles. So for the different reaction time, when the reaction time increase, the particle size of the particle also increase. So it agrees with the TEM result. Okay, for the conclusion part, in this project, synthesis zinc doped cadmium selenide quantum dots via inverse Marshall technique successfully done. And from TEM image, the particle size of zinc doped cadmium selenide obtained between 2 to 8 nanometer, and it agglomerate for longer reaction time. So when for the longer reaction time, more than 90 minutes, maybe the particles become more agglomerate and difficult to obtain the particle size. And the absorption spectra of zinc cadmium selenide quantum dot show the redshift with the increasing of reaction time. The bandgap energy quantum dot is decreased with increasing of reaction time, and the size of quantum dots increase due to quantum confinement effect. And on the basis of FTIR data, the surface of zinc cadmium selenide quantum dot mainly coated with oleic acid ligand. And the last one, the full width half maximum of SRD peaks become smaller when the reaction time increase, which show the increasing in particle size. So here I would like to acknowledge the financial support from University of Malaya under HIR grant and PPP fund. And with all that, thank you so much.